Okay, in this video we're going to learn about DeMoivre's theorem or DeMoivre's. Okay, so we have the DeMoivre's theorem. Okay, so DeMoivre's theorem makes Okay, so it says that the DeMoivre's theorem makes raising complex numbers to powers very simple. So if r cosine theta plus I sine, we have theta. Okay, so we'll make this one. If r cosine theta plus sine theta is simple complex, we have a simple complex numbers, and also if n is real number, then we will have now r, so r times cosine theta plus I sine theta will be raised to the power of n. Okay, from Algebra Trigonometric textbook by Shokowski and Cole, I will explain. We have example number 1. Okay, so it says that we have to use we have DeMoivre's theorem to change 1 plus we have I raised to the power of 20 to form A plus BI. So, and then where A and B are real numbers. Okay, so how will we solve this one now using the DeMoivre's theorem? Okay, so the DeMoivre's theorem was what I've said, so we will have now the exponent n, which is real number as well. So first thing we will do is we have to graph first. So the graph of this one will goes to here. So the point here is 1, and then this one is 1 as well. The coefficient of I there is also equals to 1. So to find the theta here and also the resultant r, so we will have now r is equals to 1 squared plus 1 squared, and then you have to square that 1, so therefore this one is equals to square root of 2. So our r is equals to square root of 2. Our theta is tangent to the power of -1 times 1 over 1, which is equals to tangent -1 times 1 equals to 45 degrees. So we can write that one in the form now. I, or 1 plus I, is equals to, we have r is square root of 2 times cosine 45 degrees plus I sine 45 degrees, right? But what if we have the exponent? Okay, so the exponent now, I, or 1 plus I raised to the power of 20 will makes us, this one is also equals to 2 times 1 to the power of 1/2, right? And then the exponent is equals to 20 times cosine 45. Or let's say we have cosine 45 is also equals to pi over 4 times 20 with the exponent 20 plus I sine pi over 4 times 20 as well. Okay? So we will have now as 2 to the power of 10 times, cut this one out, so we have now cosine 5 pi plus we have I sine, cancel out this one, the same as sine 5 pi. Okay, so with the use of our calculator, you can solve now as 2 to the power of 10 times cosine, 2 to the power of 10 times cosine 5, or cosine, how much, or you can convert this one now into, we have degrees. How much is cosine, or 5 times 180, right? So therefore this one is 900. So when you're going to use cosine 900, that is equals to, we have -1 and then 2. So this one is cosine 900 degrees plus I cos or sine, we have 900 degrees as well. 2 to the power of 10, which is equals to 1000, we have 24. So cosine to the power, or cosine 900 is equal to -1. So therefore our answer now is equals to -1024 plus, because we have to distribute that one, so what is, we have sine 900. Sine 900 is equals to 0. So therefore if you multiply that one there, the answer is also equals to 0. So therefore we have this in this form. Okay, so therefore the final answer that we will have is our A. The value of A now, so this one will be our final answer. A is equals to -1024 and our B is equals to 0. Okay, you can pause the video so that you can copy and take down notes. Okay, let's go now to the theorem of the nth root. So if Z is equals to R cosine theta plus I sine theta is any non-zero complex number, and if n is any positive integers, then Z has exactly n different nth roots. So y sub 0, y sub 1, y sub 2, and then y is equals to y n minus 1. So these roots for theta in radians are, so therefore y, k is any values. Okay, so n, or nth root of r times cosine theta plus 2 pi k. Okay, 2 pi is equals to 360 times the value of k all over n plus I sine theta plus whatever the given theta, 2 pi k all over by n. Okay, or in any equivalent, we have thetas in degrees. Okay, so you can have in degree form or you will have in radian form. For example, okay, so another example, we have used DeMoivre's theorem to solve for this. We have given complex number. So we have now to graph that one. And then around square root of 3 is approximately 1.7. So the graph is around here. Okay, so this one is 1, this one is 1, so 1.7. This one is our theta. Solve for r. 1 squared plus, okay, 1 squared plus square root of 3 squared, okay, which is equals now to 1 plus 3, which is equals to 2. And then we have our theta is equal to arctan. This is our square root of 3. This is our 1. So therefore, arctan to the power of negative 1 is square root of 3 over 1, which is tangent negative 1 square root of 3 is equal to 60 degrees. Okay, so therefore our theta is equals to square or 60 degrees. So we'll write now in the form of trigonometric. We have form of a complex. So I, or 1 plus square root of 3 I to the power of 12 is equal to 2 to the power of 12 times cosine, okay, cosine 60, which is pi over 3, right? Pi over 3 times 12 plus I sine pi over 3, okay, pi over 3 times we have 12. 2 to the power of 12 cosine, cancel out that 1, we will have 4 pi plus I sine, cancel out that 1, we will get 4 pi as well. When we simplify that one further, okay, so let's solve this one. So 2 to the power of 12, power of 12 is equals to 4,096. What is cosine 4 pi? So 4 times 180, right? So convert that one, so 720. So cosine 720 is equal to 1. So this one is 1 plus, what is sine 720? Sine 720, which is equals to 0. So therefore, the value of A now is equals to 4,900 or 4,096, and our B is equals to 0. Okay? Do you get it now? Okay, that's all for this video. Thank you so much and have a nice day to everyone.